So this is the third video in the series where I take the same Project Euler problem and give it to 4 different AI models: ChatGPT, Gemini, Grok, and Claude, with the same wording, no hints, and then I see how each of them thinks about it. Last time, Gemini came on top while Grok struggled, but the whole point of this series is that the results keep surprising me. So let's see if that pattern flips again this time. The problem comes from Project Euler, which is a big collection of math and programming challenges that get progressively harder the deeper you go. And what makes them fun to watch isn't just who gets the right answer, is that the 4 models can look at the same exact problem and reach 4 completely different solutions. So the problem this time is called minimal network, which is problem 107 and is actually really easy to picture visually. Imagine a network of 40 points, all connected by cables, and every cable has a cost. Some points are connected directly, some aren't, and the whole thing is given to you as a big 40 by 40 table of numbers. Now the total cost of all these cables is added up to 261,832. But here's the thing, a lot of those connections are redundant. If you can already get from one point to another through some other path, you don't strictly need the direct cable between them. So the challenge is to strip away as many cables as you can while still keeping every single point connected to the network. And you want to do it in a way that saves the most money possible. And the answer they're looking for is the maximum saving, the difference between the full network cost and the cheapest possible network cost that connects everything. If you've heard of a minimum spanning tree, that's exactly what this is. And it turns out the 4 models recognized a very different way to do this exact problem. So Grok went straight for the classic approach here, and honestly, it nailed it. It used the Kruskal's algorithm, which has a really satisfying logic to it. The idea is you take every single cable in the network and you sort them all from cheapest to most expensive. Then you just walk down that sorted list, and for each cable you ask one simple question. Does adding this cable connect 2 parts of the network that weren't already connected? If yes, you keep it. If those 2 points were already linked some other way, you just skip it because that would be a redundant loop. You keep going down the list, and the moment you've connected all 40 points, you stop. That's it. That's the whole minimum spanning tree. And to check whether 2 points are already connected, Grok used a really clean structure called union find, which keeps tracks of each point that belong to the same group and merges them as you go. The nice touch is that Grok added an early exit. So the instant it has 39 cables, which is exactly enough to connect 40 points, it stops sorting through the rest. The result it got was a maximum saving of 259,679. Which is exactly right. And it ran in about 1 millisecond. Clean, correct, and probably the most elegant solution out of the 4. So ChatGPT also got the right answer, but it took a completely different route to get there, and it's worth seeing the contrast. Instead of sorting all the cables like Grok did, ChatGPT used Prim's algorithm, which is sort of the opposite, where it grows the network outward from a single starting point. You begin at one point and then you repeatedly ask of all the cables leading out of the network you've built so far, which is the cheapest one that reaches a point you haven't connected yet. You grab that cable, add the point, and then repeat. To do this efficiently, ChatGPT used the priority queue, which is basically a structure that always hands you the smallest item instantly, so it never has to search through everything each time. So where Grok looked at the whole network globally and sorted everything up front, ChatGPT grew its tree locally, one nearest point at a time, and both approaches are completely valid ways to find the same minimum spanning tree, and it actually worked perfectly. ChatGPT also landed on 259,679, the correct saving amount, and it was actually a touch faster than the clock. The only reason it just comes behind Grok is that Kruskal's sorted approach is actually slightly cleaner fit for this problem, as it gives you the full table of edges. So this is where it gets interesting, because Gemini did something really smart and then tripped over a really small detail. Gemini immediately recognized this as a minimum spanning tree problem just like the others, but instead of writing the algorithm by hand, it reached for a library. It used scipy, which has a built-in minimum spanning tree function, and that's usually a great instinct. Why write the algorithm yourself when a well-tested tool already exists? And here's the thing, the actual tree it computed was correctly. Scipy did its job perfectly and found the real minimum spanning tree. But the bug was in how Gemini calculated the saving. Remember, the network is given as a 40 by 40 table, and because the calculations go both ways, every single cable shows up twice in that table, once in each direction. So to get the real cost of the network, you have to add everything up and then divide by 2. Gemini forgot that step. It added up the entire table without halving it. So its starting total was double what it should have been. And since the saving is total minus the tree doubling, the total completely throws off the final number. So Gemini confidently reported a saving of 521,511, which is way off the real answer of 259,679. The algorithm was right, the tool was right, but one missing division by 2 sank the whole thing. So Claude is actually the strange one this time because Claude understood the problem the most deeply, and that's exactly what got it into trouble. Claude didn't just want to find a minimum spanning tree, it wanted to prove the absolute minimum. So instead of trusting a standard algorithm, it directly approached the trees going edge by edge and deciding to either include the cable or exclude it, building up every valid way to connect the network and comparing their costs. Now, for the little 7-point example in the problem statement, that approach would work fine. But this network has 40 points, and the number of possible spanning trees on a graph that size is astronomically large. We're talking a number with dozens of digits. There genuinely isn't enough time in the universe to check all of them all one by one. So Claude added some light pruning to cut off dead ends, but it wasn't nearly as aggressive to tame a search space that enormous. So the program just kept going on and on and on, exploring branch after branch, and it never finished. So I let it run and eventually had to stop it. The reasoning was the most rigorous of all four models. It wanted certainty, but tried brute force to something that cannot simply be brute forced. And that's just a classic trap. Sometimes the smartest sounding approach is the one that never gives you an answer. So let's line up all four side by side. Grok used Kruskal's algorithm, sorting every cable and greedily building the tree, and it got the correct answer in about a millisecond, clean, elegant, and fast. ChatGPT used Prim's algorithm, growing the tree outward from one point, and it also got 259,679, which is the correct answer, just slightly under 1 millisecond. Gemini recognized the problem and used the library to compute the tree correctly, but forgot to halve the double table, so it reported 521,511, which is the wrong answer. And Claude tried to prove the true minimum by exploring trees directly, but the search space was so enormous that it never actually finished. So 2 correct answer, one wrong answer, and one that simply ran forever. So for the verdict this time, the winner is Grok, and that genuinely surprised me given how the last few episodes went. Grok reached for exactly the right classic algorithm, which was Kruskal's, and then implemented it cleanly with union find and a smart early exit. There was no overthinking, no unnecessary libraries used, just the textbook tool applied exactly the way it's meant to be used. When a problem is handed to you as a full table of edges, sorting them all and greedily building the tree is the most natural fit, and Grok saw that immediately. ChatGPT comes in a very close second, and honestly, you could argue either way. Prim's algorithm is just as correct. It actually was a hair faster on the clock, and the code was perfectly clean. The only reason it's second is that for this particular problem, Kruskal's edge sorting algorithm is slightly more elegant of a match. This was the closest top 2 of all the episodes so far. Then there's Gemini, and this one stings a little bit because it was so close. The instinct to use a library was actually good, and the tree computed it correctly. And it would have won points for efficiency, but for getting to divide the double table by a 2-digit right answer into a wrong one, it's a reminder that algorithms being correct doesn't matter if you feed it or read it wrong. And Claude, for the first time in this series, didn't even finish. It had the deepest understanding of the 4. It wanted to mathematically prove the minimum rather than just to compute it. But it tried brute force, a search space with more possibilities than there are atoms in a lot of things, and it paid the price. Rigor is great right up until it makes your program run forever. So the answer to Project Euler 107 is a maximum saving of 259,679, and this time it's Grok taking the crown. Same 4 models, next time, different problem.